Возвращаемся в студию. Тема
Going back to the studio, climate risks. According to the Russian Meteorological Agency, the temperature in Russia is rising 2 times quicker than globally. That means that in southern parts of Russia are experiencing more droughts. And since in Russia 2/3 of land is permafrost, and it creates marshlands really after it melts away, and satellite monitoring together with AI is something that might help here. How can it be used? Irina Petrunina, the head of the department, Ministry of Economic Development of the Russian Federation. Irina, glad to see you here. And the data scientist Nikita Zakharenko from Sber, and head of the lab and a senior member of the lab in MIPT, Shirhisv Institute of Oceanology, Russian Academy of Sciences. Hi everyone. Before going to the details, diving into details, I would like to talk about the climate risks that we put on top of the agenda. What are the main climate challenges and climate risks, and what are the technologies that help to detect and monitor them? Mikhail, can you start? I'll try. Now, the climate risks can be analyzed from different angles. One part, we have someone from the Ministry of Economic Development. From the point of view of Ministry of Economic Development, it's different. From the angle of the fundamental science, it is going to look very different. From a fundamental scientist view, we see it as a increasing of the frequency of all of the extreme natural disasters that we face, like how ocean and ocean surfaces interact with the planet. And if you look at the economy of Russia, that's a different point of view. And we can ask Irina about it, but I can suggest, I can think that going to the Arctic is going to be more intense because the ice season is becoming shorter. Apart from that, the permafrost is melting away at the same time. On the one hand, it's pretty good because we can explore our northern regions, but some of our towns are built on permafrost, so what are we going to do about that? And apart from that, in the last several decades, we see a shift of the climate zones to the north. Some species are actually migrating to the north, and that includes that really affects the health of our citizens. And we should ask the emergency ministry, how do they look at these risks, and the Ministry of Economic Development. Yeah, actually, Irina is here. What are the economic risks? Friends, I would not contradict the risk vision in terms of the science and in terms of the economy. These are the same risks. The question is about the relation to this risk and decision making to make sure that these risks are offset or even prevented. So obviously the Ministry of Economic Development sees the current problem with the climate. I think it would be really weird to deny it, that there is a problem with climate. It is going to remain, it is going to continue emerging. We have a climate agenda on the level of the ministry and on the level of the government of Russia. We are working to this end to draft a strategy to address climate and climate-related economy risks. Climate doctrine has been adopted. It is fully based on the scientific research that has been recently drafted. And actually, science is the driving factor, the main driving factor here, if you talk about climate risks and their assessment. Now, if you talk about the Ministry of Economic Vision, based on the scientific data, we look at it from two angles. On the one hand, we're talking about climate change, and we have to understand whether we can influence the climate change, maybe to put the climate warming on pause or to slow it down now. But the climate is changing anyway, and we have to adapt to that, and the economy has to be adapted to that, starting from the minimal things, starting from the municipal level, going to the national level. So we're looking at adaptation measures. What do we need to do to make sure the economy does not suffer from it, or maybe even benefit from that? So our task in these two areas is something that we do. Mitigation, this is something which we are talking about. How do you look at the climate change, and adaptation to the climate change? And technology, how does it help you in these tasks? Because, well, risks are opportunities on the one hand, but modern technologies, including AI, that we are discussing extensively during this conference, how does that help the ministry, your colleagues? I think the major trend of the government of Russia is to digitize the processes, and we are quite active in this area. According to the decree of the president, we are implementing a very important investment project on a national level. Is the monitoring of the climate active substances. What is climate active substances? These are the chemical substances that influence the greenhouse effect in this way or another, and that triggers the climate change. To understand what happens with them, you have to monitor them. Now, the Ministry of Nature, the Russian Meteorological Agency, a lot of other organizations, private and state ones, were working on that. But our task right now, as part of this very important state-of-the-art project, we need to get the climate model with a great resolution to the extent it's possible. But I understand that Mikhail has a different view on that. But anyway, this task, as part of our consortiums, is going to be resolved, addressed. I have 6 of them. These are like purely scientific consortiums with 42 organizations. So the entire beaumont of the climate science in Russia are actually gathered there, and they resolve this task. What we monitor, how we do it, with what, how do we aggregate this data. And we recently asked, how much data do we have as part of the cadastral activity? More than 10,000 data types that we actually gather and collect and process. Obviously, we need to put AI there to make sure that we can forecast properly, and this is important for us. And in terms of the economy, the Ministry of Economic Development of Russia, we want a model, a good digital model to forecast the economic development. To put it simpler, how these research and monitoring activities done by the scientific organizations can be translated to an actionable economic roadmap, and what are we going to, how as a country are we going to take advantage of that? Mikhail, AI, how do you use AI in the current in your current activities as applied AI models? How do you use that? Well, I had the AI lab. All tasks in my lab are related to AI applications, including in monitoring tasks. It's a very important task. And the question there is as follows. When we try to measure something, when we try to observe something, quite often we use the Russian Meteorological Agency guidelines minds. They say that a human has to make a final decision. But humans cannot make a final decision on everything in all of the areas of Siberia, for example. That means that we need some hardware as well as firmware and software to make sure that we replace humans in these remote areas. We look at we measure and monitor the clouds, the wind. There's quite a lot of things we can actually monitor and measure with AI. We use NNs, but it's hard to monitor the behavior of humans who do the monitoring and observations, because it's very hard to use the standard observational models. There are some approaches to that, but it's very difficult. So you have to use difficult statistical models, and these are the NNs, something that we call AI, basically. And when we talk about the observations from and interpretation of sat-nav data, well, AI is just has to be there, because if you look at the volume of the data, a human or an army of researchers won't be able to process such a huge volume of data. And that means that AI here is not to do something smart and with the precision. It's to do the same job as people do, but in huge volumes and quickly. And there is a task, for example, we are working on that, by the way, about the tropical cyclones. That's the task that we can actually demonstrate. And we're talking about processing satellite data to either determine the position or to understand where the tropical cyclones emerge, or to forecast how they move and where they're going to move. And this is obviously done by statistical models. So, but not, as far as I understand, AI is right now the removing the mundane tasks. Yeah, that's going to be like that forever, I think. We are sometimes using some of very elegant and beautiful properties of neural networks. I have published a number of articles around that, but this is, I guesstimate it to be like 3, 5, 10 years. Maybe 3, 5 years if we accelerate the process of the AI development, but it is going to be used for some more sophisticated tasks. But yes, removing mundane tasks. That's something that is AI doing right now. Nikita, I'd like to ask you how AI is used in another area. We're talking about the risks and opportunities. If you can build on that, would be great as well. Great question. A few words about the task at hand. We are now talking about tropical cyclones, and this is a very this is a disastrous event, really. It's a natural disaster that really is very dangerous. It is related to, it triggers tsunamis and extreme winds. It's very important for us because Russia, including the Primorsky region, is experiencing these tropical cyclone ramifications. And just this year, we had 2 tropical cyclones, several federal highways were flooded, as well as a number of cities and towns. Now, Mikhail has mentioned that the permafrost is melting, the global temperature is rising, and actually tropical cyclones are influencing these processes in a number of years, in several years. The number of tropical cyclones can increase double-fold. Around 85% of tropical cyclones that we see in the planet, that are forming on the planet, lead to major ramifications. for the infrastructure and for the people. That means that we need to have a tool that would help to monitor these changes, and Sber, together with the Far Eastern University, developed a monitoring system for tropical cyclones that can take information from the satellites, process them, and the AI model has been implemented in this solution, and it monitors the satellite images, and this model can detect the emerging cyclones, it can define their characteristics like the wind speed, and also it can predict the direction of these cyclones. The precision is at least 1 day. For a longer prediction period, the model has to be different, but we can predict it to up to 1 day currently. Prediction power is very important. What do you think might be the potential horizon? I think 2-3 days. And that would be a great help, because it's very important for any model, for any scientific development to be underpinned by the and used by organizations. And now our current users are the emergency ministry. They have seen a lot of potential in this work, because for them that's a separate source, important source of information, emergency information, and if they see that the cyclone is approaching, they can plan their savings operations and save lives and save health of the people, and they can plan the evacuation. So during the St. Petersburg Economic Forum, we signed a memorandum with the Emergency Ministry for developing the solution and monitoring the tropical cyclones. How difficult it is to organize the process of exchanging the climate information, because there is a lot of actors there to address the climate change. There are state players, private players as well. We are here at the Sber platform. These actors, how do they, these players, how do they share the information? Because that's money, that's a sensitive information. And what about the state actors? How are they ready to share the information? How is it difficult to organize all that sharing?
Well, I would not say that this is too difficult, because the management instruments are there. It's pretty solvable. We've got perhaps 2 areas, main areas of activity. We have been discussing the scientific track of using AI to monitor and process the data that we are getting in climate studies. But the second track is just as sizable as the various statistics that we have been collecting. And that's not just the Russian Statistical Agency, that's the various government information systems that are gathering all kinds of information from business outfits, including other as well as outfits. In management, AI is having a role to play, and we also need to integrate our management systems with what we have, with what we get in the most important innovative project. That's what we call MIPT, just to save the time on pronouncing all of it. There we are getting a global model of the world that's much more detailed, much more precise. It is going to be much more detailed for the Russian Federation. It is supposed to be used by the local governments. That's where they're going to get the information from to get good decisions and enable proper development, social economic development locally. On the other hand, we launched that for businesses. And where are businesses getting this information? And what can businesses do for climate? That's what these systems are doing. They're giving the information. So So the government information systems are getting the information for the businesses. On the other hand, the businesses can earn. Many people forget that. Yes. I've got this question on the interaction. You remember the Americom context of tropical cyclones. Who else do you work with? You know, logistics companies, perhaps local authorities, perhaps international cooperation, perhaps another case in point. Who suffers the most from that? Southeast Asia, the Russian Far East. Is there some demand for the monitoring, or do they have their systems of their own? Well, yes, that is a highly relevant question for them. Cyclones affect badly Japan, China, Vietnam. With Vietnam, we are working to scale our solution. The Japanese have their own system to monitor the cyclones, and when Mikhail spoke about the speed and responsiveness in processing this information to make some good decisions, if you compare our models versus theirs, we do updates every 30 minutes versus their 6 hours, so that's much quicker. As for Vietnam, we're working together with the Hanoi State University to scale our model. They are very interested. Okay. Yes, you wanted to add? Yes, we are doing, and the Ministry of Economic Development is doing all kinds of conversations. CIS, they are interested in what we can do in climate analysis and prediction. There are some countries who have a very high-level cadastre registry. They can take our technologies, they can take our ratios. This is a soft power, as they call it. We are prepared to provide that. People are happy to take that. And here, artificial intelligence is important because speed is very much important here. Yes, you cited a very good project with very understandable results. What about these applications, Mikhail? De-routinization, making it less of a routine. What other things can AI technologies, ML, neural networks, broadly speaking, the weaker artificial intelligence, what can these things do in fighting climate change? Perhaps this is a new front in fighting climate change? And Irina, I would ask you about the economic effect. Have we had any already from using AI in fighting for the global climate? Yes, let's start with you. Well, indeed, this is a very, very broad field of application, and we have been working with the Skolkovo Science and Technology Institute. They've got very deep it is necessary to use the speed of generating projections or modeling of geophysical processes. This speed that the neural network can deliver is several orders of magnitude higher. And it is not that erroneous. The errors are not that great. Subject to, because we have got the speed, even with small areas, we can run the modeling 100 million times, generally speaking, and we can get this uncertainty of projection that in geophysical modeling we spend tons of blood on and still fail short. Getting the uncertainty of a forecast, be it a climatic forecast, be it a weather forecast, not the same. That's very important. And this is just a whole area of activity that is crucial. Now, besides that, we've got several properties that neural networks can offer. And I'm going to pronounce some smart words. It's a differential model that can replace the hydrophysical model conventionally operated. That is pretty much underpinning the weather forecast, the climate forecast. It has not been operational yet, but we are very actively moving towards making it operational, and that will accelerate modeling even without the errors. Accelerate the modeling of physics. And these are two very interesting, very important areas. Irina, how is AI helping perhaps in building the risks models? What has been the economic effect? You are a Ministry for Economic Development. You are overseeing the climate project, but it's still about economics, is it not? Well, we are seeing the promise, we are seeing the opportunities for implementing AI. We've got the whole economic consortium led by the Institute of Economic Forecasting, and they indeed have been building the model. It has been operational. It has been scaled up based on the research that the colleagues have been doing and the information that we have been getting from the consortia pursuing natural science things. This is the application story that will help us in forecasting, in calculating the risks in economic development, that will help us with the macroeconomic issues, essentially that will help us live right going forward. Dear friends, thank you very much for your conversation. I'm quite convinced that thanks to your efforts, the climate risks globally and in Russia will find it slower to realize, and hopefully we can vanquish them at the end of the day.